So hi, my name is Jun Lai, and my talk is about chemistry in forensic science. And here's my outline. First, I will introduce about forensic science, and for the chemistry aspect of forensic, I will mainly focus on mass spectroscopy. So how many of you have watched any of the forensic TV show and thought that they were really cool? And personally, I love those shows, and I have watched a lot of them, including Forensic File, CSI Miami. And I actually wanted to be a forensic chemist when I was smaller. And everything is, because everything in the show was so cool, and then it seemed so easy to solve any cases. And the Gram labs can gather, repair, test, and then have the data from the DNA and other forensic tests within few hours. However, is it actually how forensic science works in real life? Forensic science is the application of broad spectrum of sciences to answer questions in the legal setting. In real life, the cases are not that glamorous compared to the cases in the show. And it can take hours and hours of lab work to get and analyze any type of the data. And it can actually take years to solve one case. The execution of the Romanov family is a very interesting case to look at. So here's the picture of the royal family. Here is Nicholas II, and here's his wife Alexandra and 5 of their children. The last Russian Imperial Romanov family were executed on the night of July 16, 1918. And about 60 years later, the mass grave containing the Imperial family and the attendant were discovered. However, their identity were not identified until 1991. Some DNA testing techniques were used to test the bones, and surprisingly, only 5 out of 7 members of the royal family were identified. 2 of the children, Anastasia and Alexei, were still missing. The mystery of the Romanov had become so popular that over 200 people had claimed to be one of the children since 1918. And one cool fact is that Disney actually made an animation called Anastasia related to this event in 1997. So in 2007, a group of archaeologists discovered a few bone fragments about 70 meters away from the first grave. And same DNA analysis were used to determine the identities of the remaining children. And the DNA test can be used to conclude that the bone fragments were from 1 female and 1 male children of the royal family. So this discovery has put an end in the mystery of the missing of the 2 Romanov children. So as we can see, forensic science is very useful and very powerful to solve any cases, including the case that happened almost 100 years ago. So how does chemistry relate to forensic science? Forensic chemistry is the application of chemistry and its subfield, forensic toxicology, in a legal setting. Forensic chemists can assist in the identification of the unknown substances found at the crime scene, and some major areas that use chemistry are blood analysis, fingerprints analysis, and DNA analysis. So the first analysis is the blood analysis. There are 2 tests for this analysis, the phenolsaline test and the lumino test. For the phenolsaline test, phenolsaline is usually used to confirm the presence of blood. Phenolsaline is colorless. However, in the presence of blood, which is a basic solution, and hydrogen peroxide, phenolphthalein will change to the color pink. And for the luminol test, a chemical compound known as luminol is used in the solution or sprayed directly onto the suspected area. And this compound gives a strong blue fluorescence when viewed under UV light. And this happens because luminol reacts with hematine, a substance formed at the blood stain age, and this will produce luminescence, which best observed in the dark. The next analysis is the fingerprint analysis. There are mainly two types of fingerprints, the patent and the latent fingerprints. Patent prints are visible to naked eye, so it's easy to collect this type of prints. However, latent prints are not visible, and thus we need some kind of technique to help collecting this type of print. So usually methyl-cyanoacrylate, also known as superglue, is used because fingerprints catalyze polymerization of the molecule, which will form a white solid images of the latent prints. The last analysis is the DNA analysis. DNA forensic is used in the criminal case to match the DNA of an individual to that of the body cells left at the crime scene, such as skin cell, hair, and blood. Short-term repeats, also known as the STR analysis, is the most common analysis used to analyze DNA. So with STR analysis, chemists take the DNA sample from area at the crime scene and label different motifs of the DNA chain with different color. And when the sample passes through the STR, and the intensity of each motif will be detected based on the color. And since everyone has different DNA, the data can be compared with the DNA profile using a database. And here are two examples of the STR analysis. So the first one on the top, the presence of the two peaks indicate the X and Y chromosome, which show that this sample is gotten from a male. And on the bottom, there's only one peak, which show that this sample is gotten from a female, since the peaks for both of the X chromosome were overlapped. And those are some brief description of the major area that chemistry can be used in forensic science. And in addition, in order to help identify any of the unknown substances, a wide array of methods and instruments can be used. Those include atomic absorption spectroscopy, infrared spectroscopy, and mass spectroscopy. So mass spectroscopy is a scientific method that analyzes a sample of material to determine its molecular makeup. Ionization of sample can be used to separate the compound into its individual ions, and this will allow to analyze and categorize those ions to determine the molecular makeup. And mass spectrometry can be used in the identification of explosive, controlled substances, or in hair analysis. So first, the explosive. Here are the extracted ion chromatogram for 14 different explosives. And as we can see, depend on the molecule that make up the compound, there will be different intensity for each of the compound, and also they have different mass for their ions. And we can compare the chromatogram of the unknown substance to those references to identify the explosive. So for instance, pick number 4 was nitroglycerin, which is a very well-known compound that is usually used to make dynamite. The second one is the control substances. So those are the extracted ion chromatogram for codeine, cocaine, and roofies out of body fluid. And similar to the explosive substances, these different peaks are the signature of these compounds, and those chromatograms can be used as the references to compare and identify any control substance. Mass spec can also be used to detect and image various chemicals such as biomarkers and drugs directly in human hair. So this picture is the image of cocaine along the length of the hair with 4 different washing conditions. And as we can see, the more we wash the hair, the less intensity and less signal of cocaine that we can collect it. So those are some applications of mass spec. So how can mass spec be used in a real criminal case? A 50-year-old mayor of a small village in Austria swallowed a piece of chocolate that he had found in an anonymous letter on his car the evening before, and about 10 minutes later, he needed to stop eating because of a very severe convulsions. First aid arrived later to save him, and the emergency physicians collected samples of urine, blood, and gastric content for toxicological analysis, and assuming possible cyanide intoxication. A color test for cyanide in the stomach content was performed, but no traces of cyanide could be detected. However, after several hours of using mass spec to test the sample, the urine and the gastric sample, strychnine was identified as the poison. And here's the figure that shows the concentration of strychnine in the serum and in the urine sample. And as we can see, a really high concentration of strychnine at the beginning of the graph can indicate that he had swallowed a really large amount of strychnine on that day. And unfortunately, the man died several weeks later due to the brain damage that caused by strychnine. And the murderer was arrested because traces of his DNA have been identified on the anonymous letter that's sent with the chocolate. And he was sentenced to life in prison. So the case shows the importance of DNA tests and the mass spec in forensic science. So here's the picture of me in the lab next to the mass spec. I'm very, and obviously I'm not becoming a forensic chemist, but I'm very happy to learn that my interest in chemistry and the knowledge that I have learned till now can be used and applied in in the help of solving those criminal cases. And as a student of a Jesuit school, I think this is a very important thing because it relates to one of the Jesuit value, which is cura personalis, which means respecting and caring for others. And in this case, it's the fighting other justice even after their death. So I hope now you know, you guys know a little bit more about the chemistry aspect and the significance of mass spectroscopy in forensic science. Thank you.